Welcome to Summarize Science. Have you ever wondered how scientists use AI to predict the complex dance of nature, from swirling fluids to heat movement? Usually, AI tries to predict what the next frame of a physical simulation will look like, pixel by pixel. But researchers are finding that just matching pixels does not mean the AI actually understands the underlying laws of physics. In this paper, a team of researchers explores a different way for AI to learn about physical systems. They wanted to see if a model could learn the hidden rules of a system instead of just guessing the next image. They compared two main types of learning, one that reconstructs missing pixels and another called JEPA. JEPA stands for Joint Embedding Predictive Architecture, and it works by making predictions in a latent space. You can think of latent space as a conceptual map of the physics rather than just a grid of raw data. To put these models to the test, the researchers used three different complex scenarios. These systems include active matter, heat movement, and fluid flow, all of which change in visually complex ways. First, they looked at active matter, which involves particles that convert energy into motion to create patterns. Second, they tested Rayleigh-Benard convection, which describes how heat moves through a layer of fluid. Finally, they looked at shear flow, where layers of fluid move past each other at different speeds. These systems are governed by specific physical parameters that define how they behave over time. The researchers found that if an AI can correctly estimate these parameters, it truly understands the physics of the system. As seen in their data tables, the JEPA model significantly outperformed the standard pixel-based models. It was over 50% more accurate in some cases when estimating the rules of active matter. This suggests that the AI is learning something much deeper than just what the next picture should look like. They also discovered that the latent space models were much more sample efficient. This means they could learn the rules of physics with far less data than their competitors needed. Even with only 10% of the training data, the JEPA model was still incredibly effective. Interestingly, this general-purpose AI performed almost as well as specialized models built specifically for physics. This is a big win for the idea that general AI can be adapted for highly scientific tasks. To recap the most important points, the researchers demonstrated that predicting concepts is better than predicting pixels. By focusing on the latent space, AI can bypass messy details and focus on the core physical laws. This finding shifts the focus from making pretty pictures to understanding the real-world mechanics of a system. Looking toward the future, this approach could revolutionize how we simulate everything from climate change to new medicines. It could lead to AI tools that are not only faster, but much more reliable for scientific discovery. We are moving away from AI that just mimics what it sees toward AI that grasps how the world works. It is a thrilling development for the intersection of artificial intelligence and physical science. Thank you for joining us to explore these new frontiers here at Summarize Science.